All right, so this is section 10.4 on scatter plots and function models. So we've been talking about two-way tables and qualitative data. We've been talking about more of, like, we did have quantitative because you're talking about numbers, but we've been talking on categorical data and data that could be separated into categories. Now we're going to look more specifically at quantitative data involving two variables with scatter plots. You may or may not have heard of a scatter plot before, but a scatter plot is exactly what it sounds like. It's a bunch of dots that are kind of scattered across a table. So let's consider quantitative data involving two variables. Consider the data below of the statewide average temperature in Mississippi each year since 1999. So we have all of this data. A scatter plot of the data is also shown on the following page. A scatter plot is a graphical representation of the relationship between two quantitative variables. So the whole point in a scatter plot is to look at the relationship in the two variables. So let's look at this scatter plot. All right, so looking at the scatter plot, what they did is they took the x-axis, or first of all, what do the values on the x-axis represent? Okay, they represent the years since 1999. That's pretty obvious just by looking at the label right here. So years since 1999. And then what do the values on the y-axis represent? So the y-axis represents the temperature. Okay. And then what does the ordered pair 371.4 represent? So my ordered pair 371.4. So if the x is the year since 1999, then my 3 is going to be 1999 plus 3, which would give you 2002. So in 2002, the average temp was 71.4 degrees Fahrenheit to be exact. Okay, so in 2002, the average temperature was 71.4 degrees. Describe the relationship between temperature and between year and temperature using the line of best fit. So we haven't talked about what a line of best fit is yet, and I guess this is where it's expecting us to. I'm not sure about that, but a line of best fit would mean if we were to just put a line here, if we were to take something and kind of represent this data with a line that would go through the center of the data. Would it be a line? Would it be a curve? Would it be whatever? So there is a positive linear relationship here because I have a line that will fit. It'll fit basically a line that would fit through the center. It's not curved any other way, and it's a positive sloped line. It's a positive linear relationship. So let's look at a few more types of relationships here. So classify the relationship represented in each of the scatter plots below as linear, quadratic, or exponential. So let's look at each of these. So this first one, even though it's not a very strong correlation, it's kind of separate data here, is going down, okay, at kind of an angle where it could be linear. Okay, and I'm going to go ahead and make the notion that it is a negative linear association. Okay, now this one, you'll notice, goes at more of a curve. This one was pretty linear, it kind of all falls, but this one falls more like this. So if it falls more like that, what type of function does that look like? You're right, it's exponential. Okay, and it also would be more of a negative, well, not necessarily negative exponential, let's not say that. it wouldn't necessarily be a negative exponential. It could be like a fractional exponential, but this linear is definitely negative. For this one goes up again at more of a linear relationship. Okay, and then this last one, it's still not a very strong correlation. They're kind of spread out, but it is more of a quadratic. It goes down and then comes back up. Okay, moving right along. Over a 9-month period, students at Oak Grove High School collected data on their total number of Instagram posts each month. The data is summarized below. Okay. So, over a 9-month period, students at Oak Grove High School, I just read that, sorry. So then there's the number of Instagram posts in a table, and then here is my scatter plot. The linear regression equation to fit this data is 176.32 x minus 380.47, and the exponential regression equation to fit this data is this. What is the predicted number of posts for month 11 using the linear function? So you could have a line of best fit. You could also have an exponential or quadratic equation of best fit for this one. I guess it's to say you could kind of have a line. What does this look more like? Right, to me this looks more exponential because it's kind of curving up. So what is predicted number of posts for month 11 using the linear function? So if I use this linear function down here, okay, it said f of x, I'm going to write it up here so I can slide my book back up, is 176.32 x minus 380.47. So for month 11, I would be putting in f of 11. So that's 176.32 times 11 minus 380.47. And all I have with me is my phone calculator, so it'll have to work. Let me clear that out. So 176.32 times 11 minus 380.47. So that gives me 1,559.05. Now let's make sense of this. You can't have 0.05 of an Instagram post, so that would be 1,559 posts. That would be my answer for this one. The predicted number of posts for month 11 using the exponential function. So if I were to use the exponential function on this one, then that would be g of x equals 23.30 times 1.62 to the x. So when I put in my x this time, I have g of 11 equals 23.30 times 1.62 to the 11th. So, I'm going to do this part first just to make sure. I'm not sure if a phone calculator follows order of operations. Your regular calculator, you could just type it in the yellow. But 1.62, this is your exponent key. If you're using your phone calculator, it's the x to the y to the 11th equals, so that's that, times 23.30. So that would give me 4,699.17, which means 4,699 posts. So is the linear equation or the exponential the best model from the data? So definitely for this one, the exponential, because like we were just talking about, it doesn't follow a linear pattern. Okay. It doesn't follow a linear pattern. The shape of this is more of an exponential curve. And again, we don't have to go through all the points. We just have to be at the center of that data. Sorry, I cut that off. Exponential does not follow a linear pattern. Okay, here we go. The scatter plot below shows the number of violent crimes committed in the United States for these years. The linear equation that best models this relationship is y equals negative 31,256x plus 1,773 plus 1,773,900, where x represents the number of years since 1993 and y represents the number of violent crimes. If the trend continues, predict the number of violent crimes in the year 2020. So I'm looking in the year 2020. I'm first going to have to say 2020 minus 1993 to figure out what that x value would be. So 2020 minus 1993 gives me 27. So that means that my x is going to be 27. So y equals negative 31256 times 27 plus 1,773,900. It's a little bit of a crazy equation there, but I'm going to substitute it in. And that will give me, sorry, my phone's not cooperating. I'm going to turn it sideways so it has more room here. So 31256, so negative 31,256 times 27 is that, plus 1,773,900, sorry. And so that does give me 929,988. So that means in 2020, if this trend continues, there would be 929,988 crimes, violent crimes in the U.S. Okay? There we go.